Sir, is it okay with you as well? Sure, I'm audible.
Yeah, we are in live.
Hey. Hi everyone, welcome to today's live interactive session with Dr. Umesh.
Nafisa, can you hear me?
You're pretty clear. Hello? Yeah,
Can you
yeah.
hear me? Is the voice
Ye-
audible?
Yes, it's clear.
Okay. Thanks, Nafisa. Can you say something? I can't hear you.
Uh, can you hear me now? Can everyone else hear me?
Yes, yes.
Okay. I'm not sure if I'm audible too.
You're audible, Nafisa.
Okay, thank you.
And I got the assignment 3 solution. Thank you. I downloaded
Okay.
it from what you said. Thank you very much.
Okay. Thank you for informing us as well for the inconvenience.
No, no problem. I just thought it will be nice by text. Thank you very much.
Thank you to you as well.
Shall we begin?
Yeah, sure.
Great. All right. I'll just take a couple of the questions that were already in the spreadsheet. There's a question from Pratik that asks there are birds that are found close to human settlement but not in natural places very far away from human settlements. And these are birds like the house sparrow and the common mulga. His question is why aren't these birds found away from human settlements? Is this because both humans and birds prefer the same type of habitat, or there is less risk of predation in human settlements than in natural places? So these are generalist bird species, Pratik, that um, that can tolerate or even take advantage of habitats that are very new or unusual or novel habitats that have been created by human beings. Not all bird species can do that. So when you convert, let's say, what's a forest earlier into agricultural land or into even a city, there are certain species that can either persist in cities, and these are species like, let's say, Ashiprinia, um, or red biscuit bulbul and red-banded bulbul, or there are actually species that take advantage of the fact that these new habitats are even better for them, perhaps, than what their natural habitats would be. And these are species like the rock pigeon and the house sparrow. Um, Now, they, given that these species have evolved much before human beings, right? These are much older species than human beings. So when they evolved, there were no human habitats, there were no agricultural lands, there were no cities. And so these species were actually, or even are actually, found in the wild, in habitats that actually are natural habitats. So house sparrow, for instance, would be found in areas of grassland where grass seeds are what make up most of its diet. Things like the species like the common myna are actually found in a variety of open habitats like woodland, savanna, semi-grassland, semi-forest kinds of habitat. So these birds can survive even in the absence of human dominated habitats. Whether the kinds of habitats that they are naturally adapted to are still available in the kind of area and extent that they used to be available earlier, we don't know. For example, a lot of the grassland habitat that would provide grass seeds for the house sparrow has been completely converted to other kinds of, not completely, but more, to a large proportion of that has been converted to other habitats. Um, and so it's likely that given that these birds are generally species, they would be able to survive even without human habitats. And Pratik is sharing one of his observations that he's been bird watching in North Bengal, and a lot of the woodland birds like the black-hooded oriole and the spotted dove were actually rare in the grasslands in North Bengal, and that's although the fact that the nearby woodland was actually very close to these grasslands. However, now that the grassland is slowly being replaced by agricultural land, what's happening is that the grassland birds like the cisticolas and the prinias are declining, whereas what you have coming up replacing those birds is more and more woodland birds, especially around farming settlements. Yeah, but the grassland birds are becoming rare to absent, and that's very much something that we're seeing uh, in grasslands quite across the world. But grasslands are slowly, in many places in the world, grasslands are slowly being replaced by woodland, either because of direct human activities or because of things like climate change. And you do see that woodland birds in certain locations are becoming more common than grassland birds. Although you see the opposite happening in other places. In the Amazon, for example, forests are being replaced by grassland, and therefore the forest birds are what are declining, whereas the grassland birds are those that are increasing in abundances. So Akshay in the spreadsheet asks how can the overall probability of 0, 1, 0 open model be determined as P ah uh, P times 1 minus P times 5 plus 1 minus 5. Okay, so Akshay, this is a bit of a technical question. Uh, so basically, you've got a capture history of a bird that is 0, 1, 0. That means it was not captured in the first year, it was captured in the second year, and it was not captured in the third year. Now, in the first year, it's not been captured. So we don't even know whether this individual is in the population or not. That zero could be because that individual has not even entered the population, it's not even been born. So, for example, if I start monitoring birds from 2011 and a bird is born in 2015, then 11, 12, 13, 14, I will have 4 zeros, right? Now, I don't know initially in those 4 zeros whether that bird is present in the population or not present in the population. So there are two possibilities. They're either present in the population and it's not been caught, or it's not even in the population. So what we do is we ignore that first zero or the first few zeros, um, and we start what's called modeling the capture history only from the first capture. So the first capture is in the second year in this case, because capture is 0, 1, 0, right? The first capture is in the second year. We know this bird is in the population and it's been captured with some probability P. Excuse me. Now, now that this bird is in the population, the next year in year 3, you get a 0. Now that 0 could either be because the bird is in the population, has survived with some probability, but has not been caught. caught or it's died. Yes. So that second zero, if it's in the population and it's survived with the probability of 5. That's some probability of survival. If pi is zero point 0.8, then the probability of a bird surviving from 1 year to the next is 0.8 or 80%. 80% of the population will survive from 1 year to the next, right? So if the bird has survived, so there are two possibilities, right? The bird has survived and has not been caught, or the bird has died. Survived and not been caught is the probability of survival is phi. The probability of being caught is p. So therefore, the probability of not being caught is 1 minus p. Yeah. So the probability of surviving phi and not being caught is phi times 1 minus p. That's one possibility. Or the bird is dead and it dies with the probability of opposite of survival, right? So that's 1 minus 5. And that's why you get these two probabilities for year 3. So you have one probability of for year 2, which is the probability of capture, and then you have two probabilities for year 3, either surviving and not being captured, or, which is the plus sign there, or dying, which is 1 minus 5. Yeah. What is the procedure for carrying out capture recapture method for consecutive 3 days? Is the bird released immediately after catching and identifying? And is the capture done at a particular time of the day? So the procedure of carrying out capture mark recapture for over 3 days, that the way that we do it in the field is that we put out our mist from 5 a.m. to 12 noon. So we put out our mist for 7 hours. And as soon as the bird is caught, it's taken out, measured, ringed, and released immediately. It's not kept over the 3 days, right? So we take the bird out of the net, we ring it, we measure it, we take its body weight, we take its wing length, and so on and so forth, and then measure it, and then release it immediately after measurement. Um, the capture is done between 5 a.m. and 12 noon. So that's what's in the spreadsheet from Pratik and Akshay. And I think Bani had questions for Nafisa. What's in the chat box is Gaurav has a question, which is how do we decide where to set up mistnets for missampling? So the mistnets have to be set up at least by sampling in forests, and this is what I'm familiar with. So I can tell you what we do with mistnets in the forest. The mistnets have to be set up in a place where there is a background of vegetation behind the mistnet, and that makes the mistnet more or less invisible to the bird and allows the bird to get captured. So that's what we do in every plot. We put out multiple mistnets, and those mistnets are about 40 to 50 meters in distance from each other. But they have to be against the background of vegetation. If you put out a mistnet in a place that's completely empty of vegetation, then the mistnet becomes visible, and birds will avoid that mistnet. And if we keep putting up the mistnets in the same spot every day, definitely the birds learn where the mistnets are and they avoid them. So we have found that after 3 days of putting up mistnets, the number of birds that are caught comes down very greatly. Yes, and so therefore that affects the capture probability. The capture probability comes down very much, very greatly because of the fact that the mistnets are in the same place day after day, and the birds realize that these mistnets are in these locations. So it definitely affects capture probability. Pratik has a comment. He has an experience about bird habitat is farm near college campus. It was an overgrazed field, but the authority decided to establish a medicinal plant garden. So they walled the area and planted a lot of plants. But after it was abandoned, native vegetation has grown and the diversity of the birds has increased in the place. Right, exactly. So this is something called succession, where if you abandon a place, if you abandon a plot of land, then it slowly comes back to some relatively stable vegetation type, and then the diversity of especially birds in this case will slowly increase with succession until when you get to, let's say in this case, if succession leads to primary tropical forest, then you get the maximum number of bird species tending to be in primary forest. So we got some questions from the forum, which is the curve between the number of birds and distance from the line is not a straight line decline. Does the detection probability curve follow binomial or normal bell curve or some other curve? Please clarify. So the curve between the number of birds and the distance from birds is typically does not follow a straight line. It could follow a straight line, but the detection probability can follow a half normal bell curve, because the bell curve is symmetrical, right? It's on both sides of the line. But we are talking about only one side of the line. So it can follow what's called a half normal. I'll type that into the chat box. Or it can follow what's called a hazard rate, or it can follow a polynomial. Um, and a half normal is where you're going like that. Sorry, this is a mirror image where you're going like that, declining slowly. A hazard rate is where you have a plateau and then a decline, and a polynomial is a more complex model that. But it could be linear. There's no reason why there could be situations in which the curve that relates number of birds that you see with distance from the line it could very well be linear. It's not necessarily non-linear. But the normal, what we call models, or the normal ways in which we try to fit the formula to the curve is using, most often it follows either a half normal, a hazard rate, or a polynomial. So definitely the half normal is a possibility here. The half bell curve. Do we employ variable length or variable width line? So in the meanwhile, I'm sorry, if anybody has any other questions, please do type them with the chat box while we're discussing the other questions that are here in the forum. Do we employ variable length or variable width line transits or variable width point counts? Is there any error introduced, and how to take care of the error? So let's deal with the variable length first, because that is often that's a simpler problem. Very often, the the lengths of, let's say you put out 20 transects in a forest and you're sampling birds in the forest from 20 transects. It's not necessary that all those 20 transects are going to be the same length. So you can have variable length transects, and that's not a problem. As long as each transect is at least of a certain minimum length. You don't want a 50-meter long transect, because what you're doing is on that 50 meters you're counting birds, a lot of birds at the end, a lot of birds at the beginning, and hardly anything in the middle. So what you want is long transects. Typically transects for birds, these are all thumb rules. This is nothing. There's no one correct answer for this. But typically transects tend to be about at least 500 meters long, or at least 250 meters long. When it comes to variable widths, we're talking about what's called distance sampling, right? So if you're walking along a transect, your variable, you can either have two kinds of transects, both on points and on lines. So on a line, you can have a fixed width transect where you say, I'm only going to count what's within 20 meters on either side of me. And I'm going to assume that from where I am, within 20 meters on both sides of me, I detect all the birds. And that's what's called a belt transect. You can also do a fixed radius point count, where you stand at a point and you say, I'm going to count the birds that are within 50-meter radius of me. That's a fixed radius point count. Now, the variable width point count, variable width transects at the variable radius point counts work like this, in that in the variable width line transects, you're walking along the line, but you're not saying I'm only going to count birds that are within this certain distance. I'm going to measure the distance to each bird. Yeah. And then measure the distance and the angle, and then get the perpendicular distance and so on. And at the variable radius point count, you're saying, I'm not going to only count birds that are within 50 meters radius of me. I'm going to count every bird and I'm going to measure the distance to every bird as well. Yeah. So those are variable bit line transits and variable radius point clouds. Now, yes, there is error introduced when we do these kinds of measurements. There is error introduced when we try to measure how exactly the curve goes from, in distance from the line, how the curve actually declines in terms of number of birds seen. Excuse me. Um, and those estimates come with certain errors, come with a certain standard error. Again, it's a bit of a technical question, and but basically there are three sources of errors in line transit sampling or point count sampling, variable radius point count sampling, and variable width line transit sampling. And those three errors then get sort of added up to each other. So when you actually get an estimate of population density of a bird species, it's actually an amalgamation of those three various sources of error. So that's accounted for, and it's accounted for in such a way that you can estimate bird species density very confidently, which means very small errors, or you can estimate a bird species same density with a very large error because of much more variability in the data itself. Two questions. Pratik has two questions related to. Oh, sorry, I said that only to Nafisa. The Sent that to everybody. These are the hazard rate, half normal hazard rate, and polynomial curves that we use to fit the relationship between um, distance and the number of bird species. So Pratik has a question, which is do birds related to misstanding, do birds become frightened and avoid the place of netting? So this is called trap shyness. Yes, birds do over time learn where the nets are. They don't want to get caught. But there are certain species that are trap happy actually, and they keep getting caught in the same net over and over again. But they do avoid the netting place, and that's why we net only for 2 or 3 days at a very maximum in the place, because we don't want to disturb those birds over and over again, right? We don't want to keep on going and netting in exactly the same place and then disturb the way in which they use their habitat. So we minimize the amount of time that we spend in a place. How do you tackle those people around those mentalities? Oh, this is a nice technique to catch birds. Let's try it. Two things: you have to have permission from the forest department to be able to do mist netting. You can't go out and do it on your own. You will be in violation of the law if you go out with a mist net and you start catching birds on your own without a permit from the forest department. And the forest department will only give you a permit if you're trained. So you have to show that you are trained in mist netting. And the Bombay Natural History Society is one of those agencies that does regular training in mist netting. And so you have to be trained, and you have to get permission from the state government to be able to do this kind of work. Encouraged to play call techniques, mobile phone to catch game birds in remote villages. Yes, I mean, any kind of trapping and hunting of anything is illegal as per the Wildlife Protection Act. Um, a lot of people do use nets, for example, to actually hunt. We use nets for research because we're not actually harming the bird. We're just catching them, we're putting a ring on them and bring them up. But again, you have to have permission from the government. You can't do this on your own. There was a question on giving examples about amensalism. I know this occurring in plants with allelopathy such as rice, and regarding birds have come also paper regarding the nesting distribution of blue-footed and Nazca boobies in the Galapagos Islands. Are there any other evident ones in birds? So between two bird species, maybe not as evident. See, amensalism and commensalism are sort of difficult things to measure. So theoretically, they're there, and it's possible that um, uh, You can have a pair of species where one has no impact on the other, and the other has a negative impact on the opposite species. So let's say you have a lapwing that nests on the ground, and you've got some kind of large herbivore that walks through where the nest is, and it tramples on the nests of the lapwing. Now that large herbivore gets no benefit at all from those eggs that it's destroyed, but it's a negative impact on the lapwing, right? So that would be an example of animalism, not between two bird species, but involving a bird species. From Anurag, please explain the diagram how sighting angle is worked out as difference between transect bearing and sighting bearing. Nafisa, can we do diagrams on this?
I'm not sure. There's a whiteboard, but I've never used it myself.
Yeah, I'm looking for the whiteboard there. Click on more, but I don't have any option. Oh, there you go. There's a whiteboard.
Yeah.
Thanks, Nafisa. Let me see if if I can use this. How do I draw on this? Nafisa, is there any way I can open a whiteboard myself, or can you only do it because you're the host?
Oh, am I the host right now?
I don't know. I assumed you
I
were the
think
host.
it's NPTEL they're the host
Ah,
right
okay, hang on.
There's a message saying owner of the whiteboard only allows sharing with users within the same organization.
now. Oh,
Oh, I see.
It's come on the whiteboard. I don't know. I don't know how to use it.
Okay, let me try. Let me try with.
yeah, I've never used this as well, so I'm
Like
not too
everyone is trying.
sure.
Gaurav, Umesh, Nafisa, everyone is trying. Nihar.
Okay, let me just try with so let's say you're going due north, you're walking due north, right? You're walking from south to north. In that case, the bearing of your transect is 0 degrees, right? 0 degrees is north, 180 degrees is south, 90 degrees is east, 270 degrees is west. So let's say for the sake of simplicity that you're walking due north. So if you took a compass and you point it in the direction in which you're walking, then uh, your compass will show you a bearing of 0 degrees, right? 0 degrees north. Now, if you uh, see a bird and that bird, you look at that bird and you point the compass to that bird, then the compass will give you a bearing to that bird. Yeah. Let's say that bird is at 10 degrees north. Yeah. If that bird is at 10 degrees north, then the sighting angle will be 10 degrees. Now, your bearing of the transect need not be straight north, right? Your bearing of the transect could be, let's say it's 20 degrees north. And the bird that you sight is at 10 degrees north. So it's actually to the left of you. Yeah, so if you're walking 0 degrees and the bird is at 10 degrees north, the bird is actually to the right of you. It's to the east of you. Whereas if you're walking on a 20-degree line and you see a bird at 10 degrees, then the bird is actually to the west of you. It's to the left of you. But the sighting angle will still be 10 degrees. Uh, I hope that's a little more clear, but what we'll do is we'll try to figure out this whiteboard stuff by next time. And actually draw it on the whiteboard. Which competition in cattle egret in cattle and cattle egret symbiosis? So which interaction between cattle and cattle egret? Um, it could be commensalism, where the cattle are disturbing insects. They don't care about the insects, so they don't get any benefit. But the cattle gets benefit from that disturbance of the insects, and so that would be commensalism. Um, Whereas if the cattle egret at the same time is picking parasites out of the buffaloes, while the buffaloes are disturbing insects for the cattle egret, then the cattle are getting some benefit, which is reduced parasites, and the egrets are also getting some benefits, which is increased food, and that would be a symbiosis. Dr. Anshu Arora has a question. Is lapping act as sentinel for mixed species of water birds? So actually, with the mixed species for water birds, whatever associations tend not to be typical mixed species flocks. They tend to come to the same place because there's a lot of food where they are. But yes, the lapwing is a good sentinel. The lapwing does often sound the first alarm if there's a predator, and the call of the lapwing does act as an early warning system for the other birds that are in that mixed group of water birds. Will Naveen has a question asking, will birds get frightened when they are handled during the ringing process? Some birds get traumatized on handling it. Um, I'm sure that there will be some amount of discomfort for birds as they're being handled and ringed. Um, but once we release them, and then we don't come back until 1 year to recapture those birds. So I think that the distress is minimal. It's a sort of a passing discomfort, and it's like if you stub your toe lightly. I don't know exactly how the bird actually looks at it, but if you stub your toe lightly against a chair, then you have a moment of discomfort, but that moment passes very quickly. And we know this because the birds that we ring and then we release, we sight them again and again. They're there the next year in the same habitat. So there's no long-term stresses associated with capturing and ringing. So Gaurav Ray asks, can you please explain the term trophic level? So trophic levels are basically about who's eating whom. So you have in a typical food chain, you have a producer that's producing food from solar energy, and that would be plants, typically plants, right? There's something that's eating the plants. Grazers are eating plants. So the buffaloes and cows are eating plants, and deer are eating plants. And those are what are called primary consumers. And then there are things that are eating the primary consumers. And those are called secondary consumers. And those would be things like leopards and lions and tigers and so on. So each of those is a trophic level. So the trophic level is a when you have solar energy coming in, that solar energy is converted to biomass by plants, it's converted to natural vegetation by plants, and then you have multiple levels of organisms that are either feeding on the plants or feeding on what feeds on the plants or feeding on what feeds on what feeds on the plants, and those are what are called trophic levels. So it's levels in the movement of energy from the sun to the highest level. The highest level meaning that nothing eats that thing that is at the top, and what's called an apex predator. Why do we require angle or distance in census? This count is not enough. Um, Actually, in census, you don't measure angle and distance. In the census, what you're doing is you're assuming that you're able to see most or all of the birds in the habitat. And so when you go out and count in the census, you're saying, okay, if there are 100 birds here, then I'm pretty sure that the total population size is 100. This is very similar to the census of India, right? The population census of India that happens once every 10 years, where people go out from home to home, house to house, and the idea is that the entire country will be covered. So we will know exactly how many people there are and other characteristics of people as well. But we will know exactly how many people there are in the country. The the assumption of the census is that you're not missing any individuals, and that holds true in only particular kinds of situations, right? You go out into a forest and you try to do a census of forest birds, that will not work in telling you what the total population size is. That's because in the forest, because it's dense, birds will be hidden. You will miss many individual birds. And so in the forest, what we do is not a census. What we do is sampling. We're sampling a fraction of the population. We're sampling a fraction of the habitat. And in that case, one of the ways in which to measure or estimate what proportion of the habitat and what proportion of the population we've actually missed, one of the ways to do that is distance sampling, which is asking what is the relationship between the number of birds that you see and the distance away from the observer. And in that case, to get at that relationship is when you measure um, angle and distance in the case of line transit sum. So Ramit Singhal told us the British used to keep lappings to ward off thieves because did you do it? Yeah. So lappings are often found on these large lawns and open flat areas, and they're very like Dr. Oro was pointing out, they're very quick to sound an alarm against predators. And so, yeah, the lapwings are excellent, what are called sentinel species. Trophic cascades. Trophic cascades are a situation where you have, let's say you have a lion that eats deer, that eats grass. You remove the lion. Let's say the lion gets hunted and all the lions disappear from the habitat. Then the population of deer will increase. If the population of deer increases, then the amount of vegetation will decrease because there are more deer eating more vegetation. And so the lack of the lion leads to an increase in the lower trophic level, and the increase in the number in the lower trophic level leads to a decrease in the next trophic level, leads to a decrease in vegetation. And so that's what's called a trophic cascade, where you have alternate increase and decrease in the numbers at alternative trophic levels. So estimation census sampling, census is where again you're assuming that entire population can be counted. That's a census. In sampling, you're assuming that you know that the entire population cannot be counted. So you're actually sampling a fraction of the population, right? You're actually saying, I can't count 100%, but maybe I can count 40% or 50% or 60%. But I also don't know what percentage of the population I can count. So I have to figure out a way in which I need to know what percentage of the population I've actually counted. Yes. So those are sampling techniques. Sampling is where you sample a population, where you take a sample of the population. It's like a census. Here's an example. You take a bag of rice, yeah, and you count every grain. That's a census. You take a bag of rice, you take out a cup of rice, you count the number of grains in the cup of rice, you measure the weight of that cup, and you measure the weight of the entire grain of rice. You should be able to say, depending on how many grains are there in the cup, how many grains are there in the entire sack of rice. And that's the sampling approach, which is you take a sample of that entire population of grains of rice, and based on the sample and how much that sample represents the rest of that sack of rice, you are able to tell how many grains there are. Yeah. So when you do a census, you're actually counted every grain of rice. That's a count. That's not an estimate. When you take a sample, yeah, then you're not sure 100% that when you take that sample and then you say, okay, sample is 100 grams, it has 100 grains of rice. Total sack is 1000 grams, so it should have 1000 grains of rice. But you don't know that for sure, right? You don't know that it's exactly 1000. It could be 1020, it could be 980, right? So there what you're doing is you're making an estimate. So sampling provides you with estimates. Census provides you with counts. Exactly. Census is the whole population, Ramkumar. Census is the whole population. Sample is just a representative part of the population. What reasons are there to explain that only insectivore species form mixed species flocks? Are there not any species from different guilds forms as gathering could be related to foraging? Yeah. So this is because of the distribution of the type of your prey in the habitat. Insects generally are distributed more uniformly in the habitat. You need to move to find insects. Whereas if you have something like fruit, you need to move to find fruit as well, for sure. But fruit is not evenly distributed in the habitat. There will be a fruiting tree here, and then there will be a fruiting tree, 2 kilometers away, right? So the birds that come together in a fruiting tree, or the birds that come together in a flowering tree to feed on either nectar or on fruit, are not mixed species flocks. Those are what are called feeding aggregations. They come independently. Different species come independently of each other to these feeding aggregations. That's where the resources are. That's where the food is. Whereas in the case of insects, you have a distribution of food which needs you to move constantly to try and find food. And that sort of uh, is one. It's the distribution of food in the habitat that encourages the formation of mixed species flocks. So it's the distribution of food in the habitat that is responsible for the formation of mixed species flocks. So you don't see mixed species flocks of things like you won't see a mixed species flock of hornbills and miners and orioles and barbets because that's a feeding aggregation rather than a mixed flock. Um, how does one perform waterbird census in a large lake where the waterbirds are moving about? It's a difficult thing. When birds are moving around, it's very difficult to get an accurate count. The idea is that the observer has to be moving at least 2 times as fast as the bird. So if that is the case, then you're moving fast enough to avoid double counting. Now, whether that's possible or not is a different question. So I might find a boat where I go on this lake and I move fast enough to be able to count birds very, very quickly so that I'm not double counting birds. Um, but often it's not possible. So there can very well be situations in which it's actually very, very, very difficult or even impossible to accurately count the number of birds that are there in a habitat. But the thumb rule is the observer has to be moving to some extent faster than the birds are moving. Nafisa, are there any other questions in the forum or
Uh,
there's not?
no, there are no more other questions, at least directed towards you in the forum.
Okay, there's nothing else in the spreadsheet either.
Yeah.
Yeah.
If anyone wants to ask any like final question, and type it, or I think even unmute if you want to ask.
Yes, ma'am.
Uh, you're you're unmuted.
I'm sorry.
I mean,
You're
I
on
just
audible.
wanted to
mute.
say that I'm enjoying the course a lot. And as a bird watcher, I always count the bird twice so that my count increases. I cheat because every time I see a new bird, then I'm very excited. Like then I can identify it, right? And we always see birds in two. And I really want to say thank you very much to Nafisa, who's getting us all together, and all the nice teachers. Since
Well,
I'm a teacher myself, I'm enjoying it. I'm a doctor. I'm a
well, that's
gynecologist.
oh, you're a gynecologist.
That's why
Okay.
You explained the grains of rice so well that I had to put in my cup of tea saying, census is the whole population. Because you explained it so nicely.
Thank you.
Thank you very
Thank you
much.
so
From
much.
all of us here.
I'm very glad that you're enjoying the course, and thank you to Davisa for making sure that everything runs so smoothly, and it's also streamlined. But please don't count birds two times, especially if you're putting them up, especially if you're putting up your records on eBird, because a lot of
No,
people actually
I'm
use
not
those
putting on
records to
eBird.
try.
No, all my friends do it. I don't put on. I just count it for my happiness. And I'm very sad. I was given a bird feeder as a gift, and the ornithologists were saying these bird watchers, what are they doing? They're giving aloo parathas. So, like, I'm really learning. I feel it many times. Thank you.
That's great. Thank you.
Good evening, sir. Uh, in a last assignment,
Yes.
there was one question on the form of interaction. So, exploitation, uh, interference, and apparent, three types were there.
This is
And
about
one
exploitation
question was
competition.
there, and answer is competition. So, competition is when both have negative effect, right, sir?
That's
So,
correct.
in our example of exploitation, interference, and apparent, there was no effect on other side, no, sir. There was example of tits, collar tits.
No effect on the other side.
Uh,
Tits and the collet flycatcher.
mm, yes, sir. For the example of exploitation. So,
Exploitation
is
competition.
is
That's
that
the
a
exploit.
form of competition?
Yes. So that's the example of the collared flycatcher and the tits that both compete for the same nest boxes, and that if you remove the tits, then the collared flycatchers do much better than if the tits are present. And that's an example of competition where you remove that species and the competing species, and the other species has a much better reproductive output. Now, the same would happen if you remove the flycatcher. If you remove the flycatcher and let the tits monopolize the net boxes, they would have better reproductive success. So yes, it's true that in that experiment, what they did was that they only had flycatchers, and they only excluded the tits and let the flycatchers be there. But if they excluded the flycatchers and let the tits be there, then the tits would also have had higher fitness or higher reproductive success.
But sir, there was no negative effect on collared flycatcher. It was benefited.
Yes, it has benefit.
Sir, there is one question in assignment number 716.
Nafisa, could you put that question in the chat box, please?
Yeah,
Might
sure.
let me see.
I'll just add it.
Thank you. In the meanwhile, Prateek has a question: when you study the food habits of insectivore birds of dense woodlands from droppings, how difficult is it to collect such droppings in dense vegetation? It's very difficult. You you can, I mean, in the dense vegetation to collect droppings is difficult. Sometimes you do see bird droppings in the vegetation, but you don't know which species it is. And the droppings might be old, and if they're old, then you might not be able to get information about what's exactly in those droppings. The other thing is that the droppings are often digested, and you can't really tell what the bird is eaten. So, for example, if you collect a lion, a tiger scat, what's called a scat, and the tiger dropping is called a scat. When you collect a scat and you dissect it and you open it out, you can actually identify the hairs of different kinds of prey animals. So you can say, okay, that hair is from barking deer, that hair is from sambar, that hair is from gore, and so on. Um, in With birds, it's more difficult to do that. What people have done is that they have, when they misnet birds and they collect birds, they have kept the bird in a brown paper bag for 2 minutes, and then let the bird go. If the bird is actually defecated in the bag, then what they use is DNA based approaches to say, based on the DNA that's present in this dropping, these are the species that this bird is eating. But in the wild, right from droppings, it's very difficult to get at insectivore bird droppings. But there are other species that you can get at what these birds are eating. So owls, for example, eat and then they regurgitate pellets. They digest the food and then they regurgitate the pellet. And the pellet falls to the ground, and then you can actually look at the skulls of the small mammals that the owls have eaten, and the heads of these small mammals that these. Exploitation, interference, and apparent or all forms of competition. Right. Uh, That's right. This is the question that I think this is the question that Sushila was referring to.
Okay,
Thanks, Nafisa.
no worries. Did you have any other questions that you want me to paste in the chat box?
I'm Navin Kumar. I have one question. This is
Yes.
based on biotic interaction. So effect on species A is negative and effect on species B is positive is said as antagonism predation. Can a parasitism comes under the same criteria?
Absolutely. Absolutely. Parasitism comes under exactly the same criteria. So parasitism and predation are kinds of interactions where one species has a positive impact on the other, and the other has a negative impact on the opposite species. So if you have malaria, for example, it's great for the malarial parasite because it's able to reproduce, but it's not very good for you as the host because you lose a lot of fitness.
Okay, about the question 16, what she was about to ask, like competition means both species A and species B will have negative effects, right? But in collared flycatchers and tit, only one is having negative effect. Like
Can you repeat that? Sorry.
so, competition means will have a negative effect on species A as well as in species B. But in collared flycatcher and tit experiment, and here collared flycatcher is getting benefited. Like both are not having
Ah,
negative. Right?
right. So here is the thing. So the question that we're asking is, when the tit is present, what is the fitness of the flycatcher, right? So when the tit and the flycatcher are both present and they're both competing with each other, the flycatcher has some fitness. The question now is, if I artificially remove the tits, yeah, will the fitness of the
Yes.
flycatcher increase or decrease? If the tit has no effect on the flycatcher, then the fitness of the flycatcher will remain the same whether the tit is there or not. Yes?
Yes.
If the fly tit is having a negative effect on the flycatcher, then the removal of the tit will cause the fitness of the flycatcher to increase. And that experiment shows that the tit has a negative impact on the flycatcher. Now, yes, the reciprocal experiment, the opposite experiment was not conducted, which is
Yeah.
asking if we remove the flycatchers, what happens to the tits? That's true.
Yes.
That was not done. But the answer to that would be, if you remove, and there's evidence of this from various other bird species pairs, which is that if you remove, if you were to remove in that system, if you were to remove the flycatchers, then the tits would do better, would have higher fitness.
Okay. Sure. Thank you.
Welcome.
Hello, sir. Sir, in question, exploitation, interference, and apparent, all three are there. So, in apparent, how both are getting negative effect?
In apparent, how are both getting negative effect?
A
Ah,
negative effect, because our answer
I see.
is competition.
So in apparent competition, what happens? Now, apparent competition is a very, very difficult thing to study. Um, but the idea behind apparent competition is this. Here is species A, here is species B. Both of them might not be directly interacting. Yeah. So there's no exploitation or interference competition happening between these two species. But both of those species are being eaten by the same predator. Now, if the population size of A increases, then the predator population size also increases. And because the predator is also eating B, the population size of B decreases. So population size of A increases, population size of B decreases, right? And the opposite would happen. So the effect of one species on another is through a third species, is through a species at a higher trophic level. That is what is apparent competition. It's a difficult concept. It's not easy to sort of understand apparent competition the first time you come across it. But the idea is that species A will have a negative impact on species B, species B will have a negative impact on species A, but they're not doing that through exploitation or interference. They're doing that through another species. That's what is apparent competition.
Sir, here we should consider snake as a species B.
What should we consider, sir?
Here we should consider snake as a species B and bird as a species 1.
Correct, correct. Both the species in the pair have to be considered.
Even right now, I cannot understand this question and its answer. 16 questions.
So of these three options, the only option that is correct is competition, right? Because there's no
Yes,
such
sir.
thing as
Its answer
apparent
is,
aim.
so it is applicable to all three: exploitation, interference, and apparent. So
No,
how
but
it is possible? Both are not getting the negative effect.
oh no, because there is no such thing as interference evangelism or interference symbiosis or interference predation. Right? There's a predation, there's symbiosis, and there's evangelism. So of the four options, only competition is correct. Okay,
So
I think
when
if
saying interference, how both the birds getting negative effect?
sorry, you'll have to repeat yourself, Sushila. I can't hear you very well.
Interference. There is example of tits, different type of tits.
Can you type in the chat box, please? Interference, example of interference, how both species are getting negative effect. So in interference again, it was those ticks foraging in different parts of the tree. So the idea is just to show that if you remove competitors, yeah, then the other species is able to expand where it forages. So the idea is to say that in the presence of a species, how well is another species doing? And in the absence of a species, how does that species do better, or does it do worse, or does it do the same? If you have two species A and B has a certain fitness in the presence of A, and you remove A and B does better, that is evidence that A has a negative impact on B. Now, if you remove B and A does better, then that's an evidence that B has a negative impact on A. Right? If that happens, that's competition. Now, in most cases, you only have one of those pairs being tested, right? You remove A, B does better, but people don't remove B and C if A does better. But that's evidence that's there that this is how competition works. You can remove two species from the same pair and see whether both of them have negative impacts on each other. In the examples that was shown, it was only that you remove one species and the other species does better, but we've not shown the opposite case where if you remove B, then A does better. But that evidence is there. Okay, I think if there's no more questions, we can end here. Nafisa, is that fine?
Yeah, that's fine.
All right. Thanks everyone for joining. Great fun having these discussions. And thank you, Nafisa, for setting all of this up. Yeah. See you next week or week after next, I think.
Yeah, week after. Thank you so much,
All right.
everyone.
Bye.